Every day we interact with our mobile devices, personal computers, laptops, smartwatches, and other powered devices. They have in fact become an integral part of our daily lives. All these devices, however, need to be powered one way or another. The problem lies with the fact that with the rapid growth of technology over the years came a lot of different standards for power adapters and connectors. 15 years ago, it was common to see a different type of connector on every device. Manufacturers would have a proprietary connector for each of their peripherals and charging ports because no standard connector yet existed. The same problem came with locally available voltage levels. Power stations had different voltage levels based on their location and load requirements, and since they were not yet connected to a general power grid, it did not matter. However, as nations grew and their power consumption increased, most of these voltage levels have been standardized and unified, yet there are still some variations between different countries across the world. The solution to this is the use of a universal power supply that can be used for any one of these devices. The power supply uses a USB Type-C interface to ensure that all modern devices can be connected without any problems. By using a standardized USB Type-C connector, the power supply also has the added benefit of reducing electronic waste. The power supply also utilizes the latest revision of USB Power Delivery Protocol to ensure that each connected device is supplied with an optimal voltage and power output. Power Delivery achieves this by allowing any USB Type-C and PD or Power Delivery compliant device to negotiate an optimal power output with the power supply itself. Power Delivery is also capable of fast charging any supported device. The power supply was designed to utilize a resonant DC to DC converter to ensure optimal efficiency, specifically a quasi-resonant flyback converter that utilizes soft switching techniques to minimize or eliminate the turn-on switching losses. This is achieved by forcing the voltage across the main switch to resonate and to then turn the switch on at the minimum valley voltage. The design process of both the main converter and high-frequency transformer was also included in the final solution. This allows for the design of a more specialized version of the power supply if the need arises in the future. Along with the design process, the final solution also includes a detailed spreadsheet that automates the entire design. This significantly simplifies the power supply design, since any modification to the design itself will automatically update the rest of the parameters. The final implementation of the power supply achieved an overall efficiency of 80% or higher. The following table includes the measured output parameters and overall efficiency of the power supply at 110 volt input. This shows that an increase in efficiency is directly related to an increase in output voltage and power. One of the most important things to keep in mind while designing a switch mode power supply is that it is of a critical importance to know exactly how the converter topology works in order to be able to properly design it. Getting it to work is the easy part, knowing why it works is what's important. Lastly, the importance of design iteration and prototyping cannot be overstated. The entire design process is an iterative process, and the prototyping phase is the ideal playground to test your hypothesis and validate the design choices before the final implementation can be done.